Yeah, hi guys, good evening. Good evening, everyone. Good evening. Are we live? Can you quickly confirm? Somebody on the other side? If you could confirm, that would be great. Are we live? Meanwhile, let me switch it. Yeah, hey, hi. Hi, Vinay. Yeah, are we live? Super. All right. Yeah, good evening. Good evening. Shall we get started? If you are live, all right. So Vinay has joined in. Sarthak, Anurag, all right. Hello, hello, hello. Yeah, fine then. So shall we get started? All good. The audio is coming clear. Audio is clear. Audio is clear. Quickly confirm from the other side. Somebody. Yeah, hi, Rishabh. Is the audio clear from the other end? Oh, Vanya, sorry. Yeah. Hmm. Yeah, you made it very loud, Vanya. Good. Adding couple of A's. It helps me. Yeah. Thank you. Thank you. Yeah. All right. Great. All right. All right. So let me quickly start. Meanwhile, you settle down with your pen, book. All right. So here we go. So if any new learners out here. So yes, I'm Belvi Srinivas. So I've been training since 2007. So I trained in various industries for the last 14 years. Yes, I held different positions in different industries, in different organizations when I worked. Yeah, and then I developed expertise to train students in the area of QADI and LR over a period of time. So that's briefly about me. And if you would like to be counseled or you want to seek short guidance, etc., you can reach out to me using this particular Telegram ID. You can reach me out there. So thereby, so we can interface and any short discussions we can take it up. Hey, hi Ritik and F of glad that you guys joined in. Very glad. Yeah. So Unacademy offers two kinds of subscriptions, as you might be clearly aware by now. So one of them is Iconic, that's represented by Star. The other one is Plus. So Plus offers you the structured courses, but it doesn't offer one-to-one counseling. That's the difference between the two. The Plus offers all structured courses, be it the test, all of that test, the notes, live classes. You get various kind of lectures, level 0 to level 1 to level 2, all that stuff, right? So and then different educators offer different kind of courses, and it goes on. There will be a lot of plethora of options that you will have on the platform. So in the under the plus courses, but it doesn't offer one-to-one interaction. The Iconic offers one-to-one interaction or the meetings. You can set up the meetings with your favorite educators to understand whatever be the needs. It can be the concept need, it can be the doubt could be the need, it can be the guidance, it can be the prep calendar, or it can be the test analysis, any area, or it can be a B school selection. All of that can be taken up in the one-to-one. That's what Iconic offers. Right, plus subscription, yes, these are the nominal prices on the face of it, and you can get 10% discount on these prices whenever you use any of the educator code for that matter. Yeah, you get those kind that discount of that discount. So this is, yeah, as it says, it's suitable for 21, 22, and 23. Yeah, but 21, I generally don't prefer this in case if you are preparing for CAT 21, you would like to go for it. I would rather advise go for this and make full use of it. Take enough counselings from the mentors and take full use of it. It is worth it. All of that can be worth. So because you'll not have sufficient time, with less time you might need that kind of personalized attention towards the end, maybe to realize some of your goals. Yeah. Fair enough. So already therefore the Iconic comes with a little bit of additional pricing for the simple reason that it gives a lot of one-to-one interactions with the mentors. Yeah, moreover, if you are preparing for CAT 21, so you should take this pretty seriously, either the plus or the Iconic subscription. Along with this, you will get the mocks. It doesn't matter. So you must be writing two mocks every week. No matter what, as I told you in many videos, you must be writing two mocks per week. It's a must. Otherwise, you cannot realize the top-notch scores in the entrance exams because it's relative. It's technically very, very relative game. You should be one step ahead of others. And technically, between 95 and 100%, there will be very, very tough fight. It is like, one fellow has to go up to get into that position. It is not like a score. You got 99 marks out of 100, I got 99. Doesn't matter. It is the percentile score, right? So you have to go above the others, and others are equally holding their position. Why will they leave their position from that place? So naturally, therefore, you got to put in a lot of effort, and tests is a sure way. Taking the mocks is one of the sure ways to reach, let understand and reach certain levels. That's very important there. Yeah, and this test mocks comes with any kind of subscription, be it plus, be it iconic, with any of this. But take mocks regularly if you are preparing for CAT 21. Right now, all right, from now onwards, it's very, very important to take the mocks. All right, coming back to this. So this can be a sample question on this. I'm not doing the question. I'm just trying to say that, hey, this cannot be answered by using the Fermat's theorem, right? So basically, find the remainder when 11 raised to power 50 is divided by 28. What is the remainder? Say, for example, okay, what is the remainder? Now, we can't do it by the Fermat's theorem because we understand that the Fermat's theorem, the divisor has to be a prime number. It is not, right? So therefore, let's understand that. How do we tackle this? By using the Euler's theorem. Then we will come back to this. First, let's understand. So in one of the classes, we talked about the Euler's number. Guys, give a confirmation that have you all gone through that Euler's number video? Everybody here? Dave, you are saying that I have done engineering in civil. Should I do an MBA? I need your guidance. Yeah, we will take it later. We'll take it later. Right? You ask a question, I will not have ready answer. All I know is your name and what you on one sentence you wrote. Other than this, I don't know anything about you. I can't give such huge decision, right? Because it's an investment of time, investment of money, right? So for example, Dave, you are getting into IIM Ahmedabad. You need 20 lakhs to invest and 1 year of preparation time, 2 years of college time. So can I, if one question you asked me, can I advise you 3 years of your lifetime and 20 lakhs of your investment? It cannot happen with one question. Please remember that, right? So when you see it, so because sometimes I look at some of the counseling questions that you guys ask, I'll be afraid to suggest. I'll be very afraid to suggest because I'll be asking you to lose 3 years of your time. So I don't know what are your goals, but then 3 years of your time and about lakhs of rupees of your investment. And I don't want people to repent after that, right? Yeah, they doesn't matter, yeah, whether you are from IIT Bombay, whatever. What if you are a Harvard material? Right? What if you are a Harvard material or you might be MIT material? You are on the technical side or you are on the management side. How do I know? Right? So these are not the forums, and don't take such decisions also. Even if I tell something, don't take it. If you are very rational from the other side, don't ask such questions and don't take impromptu answers like this. Right? Don't take also. That's being wise. You need to be wise. You need to have a proper counseling before you take such decisions. Right? Okay. I hope it made sense to you, Mr. Dev, from the other side. You will not just say that I said something to you. You don't even know me. Right? We need to understand each other either ways. All right? Okay. So my question, back to it. How many of you have done this Euler's number? Euler's number lecture. Quickly, guys. Quickly. To find the Euler's number for any number. Yeah. Quickly answer this question. Those who have done the Euler's number, I think Rishabh answer was yes. Prashant, Anurag, Sarthak, Ritik, Rishita, Arshita. Fapra is done. Okay. Quick. Respond to that because that's the bottom line. That's important for us because we'll just capitalize from there. Okay, Anurag has done it. Those who have done it, move your fingers. Okay, so quickly type something there. That's easier. Okay, that's easier. Okay, good. At least I got about 7, 8 responses. 8 of you are done. Others might have done, but then probably you are not in a position to respond, I guess. Okay, all right. So what did we discuss about the Euler's number? Number of numbers, co-prime to a given number less than that number. And then at that stage, we kind of consolidated this. Hey, if there is a number n, if it can be written as prime 1 raised to power a. All these are higher algebra concepts, right? Yeah, prime 2 raised to power b and prime 3 raised to power c and so on. This is what you get. The Euler's number is we generally represented by phi of n. So maybe you might have read a different book and they might have used a different symbol. That's all right there. It doesn't matter. Phi of n is generally all right. Most of the textbook kind of represent. What is this? Number of numbers less than that number and co-prime to that particular number in that particular lecture. So again, that number was titled, the lecture was titled as Euler's theorem only. But we didn't get time to do the theorem. We stopped at Euler's number. So Euler's number is therefore, let 1 n times of P1 minus 1 divided by P1. I explained why it should be written like this. So how we will get this, we saw this in the previous lecture. P2 minus 1 divided by P2, P3 minus 1 divided by P3. Something like this is what we have seen. For example, I want the Euler's number for 72. Let's say that I want Euler's number phi of 72. I am interested in finding phi of 72. So what do we write? We write phi of 72 is nothing but 2 cube and 3 square. 2 cube can, therefore I look at this 2, and we write it as 1 by 2. We look at this 3, 2 out of 3 numbers would be co-prime into till where the sample size is 72. We write it something like this, and therefore we'll say 324 times, and therefore you say that phi of 72 is 24, which means 24 numbers are co-prime to 72, which are less than 72. Otherwise, many numbers, infinite numbers are co-prime to 72. If I simply ask that, hey, how many numbers are co-prime to 72? Infinite. Therefore, I need to put a break saying that, hey, between 1 and 100, how many are co-prime to 72? Between 1 and 1000, how many are co-prime to 72? I need to cut it off. I need to give the range, right? Between which numbers? Or even I can ask that between 100 and 200, how many numbers are co-primes? Like that. But then Euler's theorem, Euler's number does not answer that. What Euler's numbers, this method answers is number of numbers between 1 and 72, which are co-prime to 70. Number of numbers between 1 and 72, co-prime to 72. This is what Euler's number story is. Okay, what is Euler's theorem? Therefore, what is Euler's or Euler's? Different professors call it by different names. Some of your professors might have called it as Euler's as well. Yeah, okay. Some of the professors might have called it as Euler's as well. Either ways, it's fine. Yeah, what is Euler's theorem? Therefore, Euler's theorem, again, if the divisor, there is a divisor. D is not denominator, divisor. And there is a base of the number. The number is an exponential number. Whenever we are applying this theorem, the number is an exponential number, a raised to power b. A is the base of that particular exponential number. What we do, these two numbers should be co-prime. First, we look at this d. It is a composite number, because if it is a prime number, we already know that we can apply the Fermat's theorem, right? Yeah. So D is the composite number. Then you look at D versus A. When you look at this A, D and A are co-primes to each other. Right? Co-prime. They should be co-primes to each other. There are three elements. Basically, in my question, what are the three elements? Number has a base, number has a power, and there is a divisor 3. So what is the order? First, I should look at the divisor. Second, I wish to look at the base of the number. And then finally, I will be looking at the power of that particular number. That's a final stage. That is the order in which we kind of take a look at this particular number. Right? Yeah. So therefore, you looked at this, okay, the divisor. So you looked at the divisor. You ensured it's a composite number. Then you opened up to the base of the number. Then you ensured that, okay, these two are co-primes to each other. Then the theorem says, I don't understand this B. There may be a B there, but theorem does not understand that B. All it understands is if you raise it to the power phi of D, the remainder is certainly going to be 1, phi of D. Now, this is where it comes. From where I get the phi of D? Phi of D I get from here. This is what you would know to get the phi of D. And this is what the Euler's number is. Therefore, you say that, hey, Euler's number is the power. If the divisor, then you write the Euler's number for the divisor, then the remainder becomes 1. This is the kind of a theorem. All right. So let's come back to the question. This is the theorem you should internalize. Somewhere you should internalize in your mind. This is all the theorem is. There is a divisor. Divisor has to be a composite number. Then you will open up, then you look at the base of the number. The base has to be co-prime to the divisor. You can't have a multiple or something like with the divisor. It should be co-prime to the divisor. That is when you now go to the Euler's number for the divisor. You find the Euler's number for the divisor, raise it to the power Euler's number. The remainder becomes 1. This is what the theorem states. Okay. Yeah. Kind of understood. Shall we do the example on this now? You kind of understood the 3-step approach. First, look at the divisor. Then you look at the base. All right, and finally you look at the power. And then what one step you do here, you find the Euler's number for the divisor. We already learned the method to find the Euler's number for the divisor. That is the approach. Steps are clear. Steps are clear in the sense like you understood where to look, what to look. You should not look other way around. Right? Yeah, it should be in a very systematic way. We should look and deal with the things. Otherwise, it simply creates chaos, confusion. There will be more confusion than clarity. Right? Yeah, because that's also a mistake people do. They don't know where to look at the number. When they look at the problem, they forget that, okay, where we need to look first, right? First look where we need to look. Okay, so therefore coming back to the question. So author is asking that, hey, 11 raised to power 50 when divided by 20, when divided by 28, what is the remainder? That's what he is asking. 11 raised to power 50 when divided by 28, what is the remainder? First step. What is the first step? First step is you look here. A is the divisor of composite number. Yeah, because if it's a prime number, I don't need this theorem in the first place at all, right? So therefore, you look at this. A, is this a composite number? Yes. And are these two co-primes to each other? 11 and 28, are they co-prime to each other? Yes. Two checks are done. What about this 50? We don't understand. What is this 50 and all? We don't understand. That we don't understand. So before that, we find out what is the phi of 28. That is the step that we do. What do you mean by phi of 28? First 28, you break them into pieces. Right? Therefore, you say that this is 2 raised to power 2 and 7 raised to power 1. Okay. Therefore, phi of 28 is 28 times of, you look at this 2, you write it as 1 out of 2 numbers would be co-prime to it. 6 out of 7 numbers would be co-prime to it. What about the power? You may say that, sir, there is a power 2 also. Ignore it. It doesn't matter to us. Okay. Yeah, this is what you write there. So therefore, 14 2 times and 6 into 2, 12. Therefore, you say that phi of 28 is 12. 12 numbers are less than 28 and they are co-prime to 28. Fair. So now, therefore, what Euler's theorem states? Euler's theorem states that I don't understand this 50. What is this 50? I don't know. You take care. Theorem only states this. If you divide 11 raised to power 12, this 12, I'm bringing it here. If you divide 11 raised to power 12 by 28, it guarantees a remainder called as 1. It guarantees a remainder called as 1. What about this 50? That is left to us. That's your business. You do whatever you want to do. And exactly what we did with Fermat's theorem. Please watch that lecture on the Fermat's theorem if you have not done that. We go with the cycles of 12, because how many cycles doesn't matter. If 11 raised to power 12 is divided by 28, the remainder is 1. Then 11 raised to power 12 raised to power 3 when divided by 28, the remainder would become 1 raised to power 3. This is what we kind of learned there. You may wonder why, 4. All it raised to power 4, the remainder becomes 1 raised to power 4. You may wonder why 4, because I'm going closer to 50. 12 4 times is 48. Therefore, you say that, okay, what is left now? Another 11 raised to power 2 is left now. So therefore, this side also I will multiply by 11 raised to power 2. Why? Because I need to match with 11 raised to power 50. 11 raised to power 12 into 4 is 48. And I need another 11 raised to power 2, 11 raised to power 2, which makes it to 50. So if I'm multiplying left hand side by 11 raised to power 2, I need to multiply right hand side also by 11 raised to power 2. 11 raised to power 2 is nothing but 121. You can't say that when divided by 28, the remainder is 121. That's not possible. Therefore, you divide this by 28 once again. All right, you divide this by 28 once again. 28 4 times. All right, which would become 112. Therefore, 9 is the final answer. 9 is the final answer. However, what we generally do is, so we know that, okay, this extra piece will be there, 11 square extra piece will be there. How do we get that extra piece? All we do is, once we understand the Euler's number is 12, here we don't do this, below this portion we don't do. Instead, once the Euler's number is 12, remove the cycles of 12. Why? Courtesy Euler's theorem, we know that every cycle of 12 gives me 1 as the remainder. So therefore, I'm not interested how many ones I get. I remove the cycles of 12. 12 fours are 48. So list out the remainder here. Once solid, now you divide 50 by 12. You are removing the cycles of 12. 12 4 times 48. Focus on the remainder. Therefore, what is that extra it's left with? You are left with 11 raised to power 2. You divide this by 28 and list out the remainder as 9. This is how it could have looked for you once you find the Euler's number. Okay, is it making sense? Clear? The theorem is clear. Application is clear. Is this clear? Are we ready to play with the theorem now? Quick confirmation. Give a quick confirmation. Are we ready to play with the theorem? Or was I very fast? Should I explain once again? Was I too quick? But if you are following from the formats onwards, you don't feel that. See, suddenly you join somewhere, then it might be a problem. But you did formats with me, Euler's number with me, and if you are doing this, you don't feel it, because it's all already discussed. It's all already discussed. Most of the properties what we are using here have been already discussed, except the Euler's number. And then we just have to learn to play with this now. Already we have to play with this theorem. Now that we understood that theorem, we got to play a little forward, backward, all that stuff. Right, to bring in that effectiveness. Technically, already now knowing these theorems will help us to solve the questions on remainders in less than a minute. That's it. That's all the advantage. Why we should know theorem? Without knowing theorem also we can do. But the point is, it might take little longer time. Knowing the theorems, generally we can close most of the questions in lesser time, maybe about a minute's time, right? Maybe about a minute's time. Some of them may take much longer, yeah, but then generally most of the questions will be able to close it. Yeah. Fair enough. So here we go. Very simple question. Here we go. Why don't you guys try it? Why don't you guys try it? Try it and give me the answer in a minute's time. So recall the properties that we discussed from the previous class. All things what we discussed about remainders from the previous class are applicable, plus this theorem what we did today. Hmm. Why it's taking time, guys? What happened? Are we connected? I was expecting an answer. Okay, do it with me. One more question. Do it with me. Probably you'll get into the groove. Where did you went wrong? First of all, a 99 when divided by 66, the remainder is 25. I told you, right? I told you that A should be less than D. When A raised to power B is divided by a divisor, we already said that A should be less than D. There is no point having 91 there. Bring it down. Make that always less than the divisor. 91 is greater than divisor. Bring it down. A should be less than D. This property we clearly discussed already, because no point. Smaller, better for us. The smaller the number, better for us it is would be, right? Okay, first let's do that. So 91 divided by 66, it becomes 25. Fair enough. So that is 25. But the author said that, hey, it is not 91, man, it is 91 raised to power 63. Okay, then it is 25 raised to power 63. Okay, 25. You can further write, already you can write 25 as further 5 square, because you think that I'll get more control by writing this number as 5 square. Sure, then you write it as 5 square, the whole thing raised to the power 63, right? So therefore it will become 5 raised to power 126. I'm fine with it. Smaller the number, better is the control, faster is your control. That's all the idea is, right? You would be much better off. So that's the first thing. That's the first thing. You never accept a number which will be greater than the divisor, which means base of the number. Base of the number need not be greater than the divisor. If that is the case, immediately bring it down, make it smaller, bring it down and make it smaller. Okay, fair enough. So this number is greater than 66. Therefore, you will divide this by 66. First thing is find the phi of 66. All right, find the phi of 66 there, right? 66. Or you may say that no, sir, I will do 5 cube. From there also I will proceed. That is also fine. That's also perfectly fine, because 5 cube when divided by 66. All right, now so you understand that that would, yeah, maybe. All right, that's a little tricky number. May not be a great number to follow. Yeah, let it be phi of 66. You write this as 66 times of a, what is 66? 66 is 2 into 3 into 11. Therefore, you say that, hey, 1 by 2. You look at this 2, you write 1 by 2. You look at this 3 and you write 1 by 3, 2 by 3. And you look at this 11, you write 10 by 11. This is what you kind of write there. Okay, 11, 3, 2 is 66 done. So therefore, phi of 66 is 20. Implies what? Hey, remove all cycles of 20. You are trying to remove every cycle of 20 from there. And hence you are left with 5 raised to power 6 divided by 66. This is the kind of number left. Okay, you will know 5 square, 5 cube, 5 power 4, whatever. You can split this. 5 raised to power 6 is there. Can I split this as 2 5 raised to power 3? Split it. You may say that no, sir, I will do 5 square, 5 cube and then 5 raised to power 4 and 5 square. Do whatever you want to do. Consistency is better, because if you do 5 cube, you will get another 5 cube number also. That's my point. Okay, 5 cube divided by 66. You are repeating this number as 5 cube by 66. 5 cube is 125. 125 divided by 66 two times is 132. So write the negative remainder, because you are saying that, hey, this is 125. 56 into 2 is 132. Write the negative remainder minus 7. So therefore, from here also you will get another minus 7. This also will lead another minus 7. Fair enough. So therefore, minus 7 into minus 7, 49. Is 49 less than 66, which is supposed to be your divisor? Is this lesser? Yes. Then accept that as the answer. And hence you say that 49 is the answer. Doesn't take much time. So all you could have done is what? Quickly reduce this number from 91 to 25, and immediately you write it as 5, all at power of 5. Once you write the power of 5, all the effort goes in what? To find out what is the Euler's number for 66. Once you get the Euler's number for 66, you get rest of the answer faster. Making sense? Everybody clear? Some of you took longer time, so I expect that you guys get a little faster now. So I know that 10 o'clock may not be a great time, but if you have taken a power nap, then it is okay. All you got to do is what? Sometimes you just have to take a power nap or have a cup of tea or coffee, right? And then sit for the lecture. And sit straight also in the night. Because if you sit on the sofa here, there, on the bed, all of that, then you will be half asleep already, right? Create the right environment for study, especially in the night and the afternoon. All right, especially in the night and the afternoon, you have to create the right environment. Yeah. Hmm. Okay. Right. Okay. Great, Amit. Glad to have you here. Glad to have you here. Glad to know. Yeah. Fine. So, guys, others, what happened? Rishav, Anurag, Sarthak, Prashant. How about others? How about others? You got it, not getting it? What's happening? Can I quickly know? Others are there in the meeting, not there. So, are you getting this? Okay. Ritik is fine. Harshita, are you there? Vinya, are you there? Are you getting this? Because with this, we could have kind of nailed down the concept. We can only do the applications now just to check how we are progressing. Because if there is a doubt, ask me here itself. Yeah. Got it? Okay. All right. Nazia, you also got it. Super. Super. Yeah. Yeah, fine. Then let's model it because now I will not ask for too much of reconfirmation. If you got this much, then it is done. It is kind of concept is nailed. We just have to look at some of the applications. And then I will set up the tone to find the last two digits as well. Last two digits or last three digits of the numbers as well. I will set up the base, but we will deal it in a different way. All right? We will learn to deal it in a different way. But let me set up the base in this lecture. Right? I will set up the base for it as we go along. Yeah, this was the CAT question. This was the CAT question. CAT question. I think just some numbers changed here, right? Some numbers changed. I don't remember which number I changed. I changed only one number. Otherwise, this is the CAT question. Just one number changed in between. That's why I'm putting a star. CAT like, right? Yeah. Just to prove a point, I just changed one number. Okay. Yeah. Okay. Thanks, Nazia. Thank you. Yeah. Go ahead, guys. Try this. Try this question. I will put the timer. I will give 2 minutes. I really want you to solve this question. Yeah. Take 2 minutes. Keep your pen. Take your book and start solving. Don't be a spectator. I don't want the people just watching the screen. Exercise your brain. Yeah, take a pen, take a paper, start solving. Hmm. Okay, no worries. Do it with me. You might have almost done it. Almost done it. Do it with me. Yeah. The second part is pretty clear. This side of the part is pretty clear. 7 raised to power 268. Listen, the chances that the other side, the people may make a mistake. All right, here, this side, people may make a mistake. 469 by 22 side, the people can make a mistake. Let's understand what can be the mistake there. First, let's nail it down the right hand side. This will nail it down. Right hand side will nail it down. Then we will come back to the left hand side. Right hand side, let's finish the right hand side. So Euler's number for 22, Euler's number for 22, that is 22 times of 1 by 2 and 6 by 7. We know what is 22. 22 is nothing but 2 into 11. So 2 into 11, therefore you write it as 10 by 11. Sorry. Yeah. This is what you kind of do. Therefore 10, Euler's number for 22 is nothing but 10. Remove the cycles of 10 from here. All right. We remove the cycles of 10. Therefore you will be left with 7 raised to power 8 divided by 20. Okay. So I will take 7 square onwards. 7 square when divided by 22. The remainder is 5. Remainder is 5. But I want 8. Therefore 7 square raised to power 4, because I have to match with this 8, 4. Therefore 5 raised to power 4 I will do. 5 raised to power 4 in your mind, if you want, take it as 5 square and 5 square. There is no problem. This you should divide by 22. I'll divide this by 22 and 22. That's what isolation technique. We divide and rule, right? Okay. So therefore 3 here and 3 here. And hence you say that, man, this side the remainder is 9. This side the remainder is 9, which is easier. This side of the remainder is not a problem. Fair enough. So this side I got it as 9. Now let's go to the other side of the spectrum. We can't. All right, now 22 is fine, but 2 is not a co-prime. 2, all right, I see here. 22 and 7. All right, if you look at the other side of the spectrum, 22 and 7, it's all right. But when you look at 22 and 2, 2 is not the co-prime. First, what we need to do, therefore, hey, take a 2 outside. Take a 2 outside. And hence you say that, hey, this number is 2 raised to power 468 divided by 11. I can apply directly the Fermat's theorem on this. On this circle, I can apply the Fermat's theorem. Fermat number for 11 is 10. Therefore, remove the cycles of 10. And hence you are left with 2 raised to power 8 divided by 11. This is the number that you have. What is 2 raised to power 8? 2 raised to power 8 is 256. 256 divided by 11. We get the remainder as 3. Okay, therefore the remainder is 3. But the point is, hey, there is a 2 by 2 outside. You didn't use it. Therefore, we said that, hey, when the number is divided by a divisor, if it leaves the remainder r, then k times of the number divided by k times of the remainder will leave k times of the remainder, k. What is that k here? This k is nothing but 2. This is k is nothing but 2. Therefore, I need to multiply this also by 2. Okay, I also multiply this by 2 in a sense. So here there was always 2 outside. Remember that 2 was not going anywhere. We are not cancelling. We were just keeping that fellow out. We were just keeping that fellow out. The bracket gave me the remainder as 3. All right, this bracket gave me the remainder as 3. But there is a 2 outside. 2 into 3 becomes how much? 6 from this side. What is the required answer? 6 plus 9. 15 would be the required answer. Guys, did you get this? Everybody clear on this? Everybody clear? All good? Making sense? Confirm? 15 clear? All clear? Yeah. Okay. Okay, somewhere this side the people make a mistake. People make a mistake on this side. They'll forget. All right, they'll forget. They'll simply all right now take that and then they will start applying it. They'll forget to keep this 2 by 2 outside. They'll forget to keep this, which is kind of important. All right, now that's where people make a mistake and they end up with a different answer. They will end up in a different answer. The other side, right hand side, is pretty straightforward. The left hand side is where kind of people make a kind of a mistake. I hope I'm not fast. All right, yeah. Good, good. All right. Very nice. Prashant made a mistake. Yeah, I know. All right. People generally make a mistake there. Yes. Okay. Now, first question, I expect an answer. I expect an answer. The first question. First question, I expect an answer from everyone. Everyone, I expect an answer. Yeah. Second question is where there is a criticality. This is what we learn. This is the learning part of this slide. This is the learning part. We almost came to the end of the lecture. Only one theorem I'm teaching because this was the backlog. This theorem was the backlog. Was not actually today's syllabus. This was 3 or 4 days back syllabus. Anyway, we'll do this. First question, everybody give me the answer. That gives me a sense of confidence from the other side. Look, trainer also needs a confidence. As much as student need a confidence the other side, trainer also needs that confidence that yes, we are getting it. Yeah, I can get that confidence by giving very easy questions. That doesn't make sense because they don't help us in CAT. Right? Trainer can get a false confidence, pseudo confidence. What is pseudo confidence? Give a easy question, everybody will answer, but that does not take us anywhere. It is like giving a 2 kg dumbbell and asking you to lift, and everybody will lift and will say that well done, guys. That doesn't make sense. Hmm. Not pseudo confidence. True confidence is what I want. Okay. First question. Everybody nailed the answer for the first question. All of you, take your pen, take your book. I'll wait. I have not put the timer also. I will wait. Hmm. Hmm. Yeah, Prashant, put your answer. Vanya, Nazia, and others. I might have missed some names. Well, whatever. Yeah. Is it taking time to type? You're having a difficulty in typing. Use laptop, guys. Use laptops or desktops, whatever, so that you can communicate better from the other side. Yeah, okay. 5 of 49. First thing is we'll take 5 of 49 because others are fine. Others are fine. 6 is fine. 6 and 49 are co-primes to each other. All that is fine. What is 5 of 49? 49 times of 6 by 7. It is 7 square. 49 is 7 square, but power is nothing to do with us. It's only the base what matters. Right? Therefore, you will write this as 49 number times of 6 by 7. 7 times. Therefore, you say that, man, this is 42. Pi of 49 is 42. Therefore, what? 6 raised to power 42 when divided by 49, the remainder is 1. This is what Euler theorem states, right? This is what it is stating. But the point is, I want 6 raised to power 85. I'm not interested in 42 when divided by 49. What is the remainder? I remove the cycles of 42. Why 42? Because Euler's theorem, Euler number is 42. I remove the cycles of 42 from here. So thereby, all it we leave with 6 raised to power 1 by 49. What is 6 raised to power 1? Remainder 6 itself. Very simple question, right? Yeah. Right. Okay. So already, therefore, already this becomes 6. Fair enough. Now listen. Listen to this carefully. Now there is a learning part. Start this. You guys start this question. You will understand where the difficulty is. Then I will come back. All of you try this. Try this. Just start. Take 30 seconds. Start this question to just start the question. I will close it. Start this. Nazia, some of the lectures are on the app, special class. I took that on the special class also. You're asking that where is some of the DILR, some quant also, continuation. If you look at TSD, some continuation of TSD or some continuation of allegation, mixture, all of this comes in the special class also. Okay, yeah. If possible, I will put the playlist. Some of them are on the special class. That might create a confusion. Some part of your DILR is also on special class. That also shifted to special class. Some of them are shifted there. Therefore, you will find a gap sometimes. Yeah. Any which ways. Yeah. Okay, fine. You started. Now listen very carefully. Listen, guys. Everybody listen carefully. Listen, everybody listen. So now I am asking that, hey guys, 6 raised to power 83 when divided by 49, what is the remainder? right? Again, we solve these kind of questions, no big deal about this, right? No big deal about this. 83, right? 83. But we know already, hey, 6 raised to power Euler's number is 42. Same question, absolutely same question. I only changed this number. 85, I made the power as 83. That is what we made there. Okay, 6 raised to power 83 when divided by 49, what is the remainder? That is what we are kind of questioning. But again, you start, because now, so if you go forward integration, you do this 42. 6 raised to power 42 is what you will do. If you remove 42 out of this, then you will say that, man, I am left with 6 raised to power 41 by 49. How will I deal with 6 raised to power 41 by 49? That becomes a problem, right? That becomes the problem. So when it is closer, all right, no, because it is 41 is closer to 42. In other words, see, after doing this, you kind of realize, all right, from here you realize that 42 multiple 85 is very, very closer to 84. Start there. Therefore, this is what you want. This is what you want. Now listen, backward integration. Sometimes we do forward integration. Sometimes we do backward integration. I'm teaching backward integration. Sometimes it is nice to look backside rather than looking forward, because forward will become too many manual steps. Now looking backward. Okay, why forward is too many manual steps? Let me do one step on this question first. Let me do one step. So 83, cycle is 42, where I'm getting 42 here. This 42, I'm using it. This 42, because 5 of 49 is 42. Okay, I use that 42. Forward integration, 6 raised to power 41 divided by 49. This is what I got. I stopped at this because 6 raised to power 41 is still a big number, followed by 49. I can't. Therefore, I look at this. Now I will say that, man, I know that. Right? I know that. What do you know? I know that 6 raised to power 42 when divided by 49, the remainder is what? Courtesy, Euler's theorem. Hey, what is the courtesy here? This is because of Euler's theorem, right? So therefore, all it now from here. So now what you want here, but I want 6 raised to power 41. Break this, therefore break this. 6 raised to power 42 can be written as 6 raised to power 41 into 6 raised to power 1. What did I do? I didn't do anything. I only changed the numerator. Okay, by 49, my remainder still should be still 1. Why? Because I only made a cosmetic change to the numerator. I didn't make any other change otherwise. Okay, so therefore, how do you write this? This by 49. This by 49, divide and rule policy. Fair enough. So this gives me 6. This gives me 6. What is the remainder from here? K. 6k when divided by 49, the remainder should be 1. That is where I stop there. What is the value I want now? Therefore, the value of k. Value of k is what I'm interested. 6k when divided by 49, I want the remainder as 1. This is what we are talking about. Fair enough. So let us stop 6. Solid now multiples of 6. Hey, 6 one time is what? 6. 6 divided by 49, remainder is not 1. Keep doing it like this. When you go to, when you get the number or the multiple of 49, listen carefully here. So either closer to 49, 1 less than 49 is also fine, which means 48 is also fine for me. 50 is also fine for me. Or multiple, all it now 49 2 times. What is 49 2 times? Which will become 90. All right, which would become 98. So I am okay with 97 also. I am okay with 99 also. Something like that. Plus or minus 1, I am fine. Remember that. Plus or minus 1, I am fine. So plus or minus 1, if you are fine, you understand that, hey, 6, 7, 6, 8 times, 6, 8 times 48. I'm comfortable with that. So therefore, I will say that, hey, in that case, the value of k, I will write it as minus 8. Minus 8, because when minus 48 is divided by 49, the remainder is 1. Minus 48. Hey, how do you know that minus 48 is divided by 49, remainder is 1? Simple. Add divisor to this. For minus 48 as a divisor, you will get 1 as the remainder. Naturally, you will get 1 as the remainder. So therefore, even if I get a minus 1, I am okay. This is the trick people should know. Whether the plus 1 I am okay or minus 1 also I am okay. So what is that you are writing? Minus 8. When I put it as 8 here, look at this. First I get 8 in my mind. 6 into 8, 48. 48 divided by 49, remainder becomes minus 1. Okay, if it 48 divided by, see, 48 divided by 49, the remainder becomes minus 1. However, minus 48 divided by 49, the remainder becomes 1. Remainder becomes 1. Okay, fair enough. So therefore, what you do, it is becoming minus 1. If I want to make it plus, make minus here. If you make minus here, it is matching with my outside remainder. Therefore, you are saying that the negative remainder is minus 8. When all at 6 raised to power 41 divided by 49, the negative remainder is minus 8. Therefore, what is the positive remainder? Positive remainder is add the divisor back. When you add the divisor back, positive remainder becomes 41. Are you getting this trick? Is this trick clear to you? Going backward is clear. Backward integration is clear. This is all the last thing that you have to learn on this. This is the backward integration. While doing backward integration, plus or minus 1, it's fine. Plus or minus 1, it is fine. See, you looked at you have to go up to 6 raised to power 41. I'll quickly repeat. 6 raised to power 41 is what you need to get, right? But 6 raised to power 41 is close to 6 raised to power 42, which gives 1 as the remainder. If that is the case, you break that. Take this 6 raised to power 42. Look what you want. You wanted this. All right, from here you get 6 as the remainder. But then 6 into something when divided by 49, getting 1 as the remainder, if it takes time, it's okay. 6 into 8, go to a multiple which is closer to 48, plus or minus 1, close to 49, maybe 1 more than 49 or 1 less than 49. Either side it is fine. Either side it is okay. That is the point I'm trying to make. Okay, so now you understood that 6 into 8 is 48. 6 into 8 is 48, but 48 when divided by 49, it will not give the remainder as 1. So therefore, you make this minus 8 so that the remainder would become positive 1. But now you are saying that, hey, when 6 raised to power 41 is divided by 49, my entire remainder has become minus 8. I will not accept minus 8 as the answer. So therefore, come back and do this particular portion. Kind of steps are clear, everybody? Steps are clear? Steps are clear how to look backward, two ways, look forward and look backward. Both we should know with respect to the theorems. Looking forward, looking backward. Sometimes it is wise to look backward, sometimes it is wise to look forward. Both points are clear with this. Both the points are clear. Confirm quickly. Guys, other than Rishav, Anurag and Prashant, others are not getting it what we are trying to say. Okay, we'll do one more question in that case. Let's try one more question. Yeah, try only this. Okay, you want to try this, you try this first. Okay, try question 1 and everybody can give the answer to question 1. It's an easy question. This is easy. This is an easy question. Go ahead, give me the answer to the first question first. Quick, quick. That's easy. Everybody try and give me the answer. Mm. Okay. Mm. Yeah, this is okay. This is simple, straightforward, forward integration, straightforward. Phi of 25. Phi of 25 is 25 times of 4 by 5, right? Therefore 20. So therefore you look at 6 raised to power 62, remove the cycles of 20. You will remove the cycles of 20 and hence you will say that you are left with 6 square divided by 25. 36 divided by 25, 11 is the answer. Forward integration. Okay. Now all of you try the backward integration. Try the second question now. Take time. Take time. Do the backward integration. Ready? Already this is ready. Phi of 25. Phi of 25 is 20. You are ready. Ingredients are ready. Just use the ingredients. Use the ingredients. Ingredients are ready. You just have to use it on the second question. That's it. Hmm. Okay, if I give a little more time, you guys will close it. No worries. All right, do it with me. Do it with me. We'll close it otherwise. No worries. Yeah, okay. So we understand that 6 raised to power 60. I will take it 6 raised to power 60. I'm looking at 58 here. I will take it 6 raised to power 60. Why? Because cycles of 20. 6 raised to power 60 when divided by 25, the remainder is 1. That much I know. Because already cycles of 20. I already know the cycles of 20. Cycles of 20 very close to 58 is what? 60. I will go up to 60 when divided by 25. The remainder becomes 1. Very good. But then I want 6 raised to power 58. So therefore I will look at this 6 raised to power 60. I will break it. 6 raised to power 58 into 6 raised to power 2 when divided by 25. The remainder has to be 1. Fair enough. So this gives me 11. 11 and this will give me k. 11 into k when divided by 25. The remainder has to be 1. 11 9 times 99. 11 9 times 99. But 99 when divided by 25, the remainder becomes minus 1. Therefore, what I will do, I will not take this 11. I will not take this 9. There is a 9 here. 11 is already there here. I can't change it. 9 is where I can change. Therefore, 11 times of minus 9 becomes minus 99. Minus 99 divided by this, my remainder will become plus 1. Therefore, I say that this k value, therefore the value of k is equal to minus 9, which means remainder. What is value of k? You are trying to say that 6 raised to power 58 when divided by 25, the remainder is minus 9. I am not interested in the negative remainder. Then add back 25. Add the divisor. If you add the divisor to this, then you will be getting the number as 16. 16 becomes my answer. Comfortable? Everybody understood this? Clear, my friends? Everybody clear? It doesn't take much time. Backward integration doesn't take much time. You just have to practice it. How you do the forward integration, likewise you got to do the backward integration. And be comfortable using plus minus signs. Right? Be comfortable using a positive remainder, negative remainder. Your final answer has to be positive. That's it. In between, you can play with plus or minus 1. I told you in the first lecture itself, plus or minus 1 is a very preferred remainder. Plus or minus 2 also, plus or minus 3 also. I didn't speak about that. That's a different issue. But plus or minus 1 is the most preferred. Most preferred. Right? Hmm. Yeah, Abhishek, you are saying that are you from South India? Yes, I'm from Bangalore. I'm from Bangalore. I stay very close to IIM Bangalore, alumni of IIM Bangalore. I hope it answers all your questions in one go. Yeah, all right. Okay, so there we go. That brings me to the closure of this lecture. Good enough. Solid. This is good enough for now. So I guess yeah. So quick couple of things. So what we'll do tomorrow is we'll do games and tournaments. We'll start with games and tournaments at 2 p.m. tomorrow. Yeah, some basic foundations we'll discuss 2 p.m. in the afternoon. Tomorrow we'll do games and tournaments. Round robin concept is what we'll discuss. There are a lot of concepts in games and tournaments. We'll discuss round robin concept tomorrow. Tomorrow night, again at 10, we'll do one last theorem. That's the Wilson's theorem. And we'll also do few other types along with the Wilson's theorem. Basically, we'll take it as some remainders basically. So we'll talk about this. Basically, Wilson's theorem, and along with that, we will do a little bit of things which are left here and there. We will cover that. That is the thing for tomorrow. Tomorrow we have two lectures on YouTube, both on YouTube, one at 2, one at 10. And yes, so I'm doing the algebra series, the entire algebra series I'm doing as a free special class that's on the Unacademy app. So if you want to follow what we are doing on the algebra side, so you follow the Unacademy app. So kind of I'm doing about 3 to 4 lectures per week on the Unacademy app there. So I finished one today as well. So and we'll be doing it back again on Wednesday. Wednesday 2 hours. So I'll spend 2 hours there with 15 minutes break, 6 to 8:15. We'll take one coffee break of 15 minutes, and we'll be doing the algebra there. I will let you know the topics tomorrow. So because I'm picking up some impactful topics and we are trying to study that. So for this, you may have to download the Unacademy app just in case. If you have not downloaded the Unacademy app, download it. Then use the code Belvi100. So use that particular code while downloading. If it asks for a referral code, you do that. Yes, before you leave, if you have liked the content that we are discussing, so you can always press the like button and leave. Even if you are doing it offline, doesn't matter. You can press the like button after you listen to it, and you can share the link with your friends as well. That would be encouraging to the other side, person on the other side also, right? Yeah. Yeah, some of the finest educators have about to launch few courses on 15th of September, and one targeted for 21 revision, the other one for 22. You can take a look at this. If some of them suits your need, you can enroll and you can take those programs, right? I am also starting the plus course on 20th of this month. right? 20th of this, that's Monday, I guess. 20th, I'm starting a plus course, but I'll be doing it individually. I'll be doing it individually. I will not be doing in collaboration because I will have a little bit of timing issues here and there. Therefore, I'll be doing it individually there. So I will let you know what topics I'm planning to take, all that stuff. Yeah. Yes, this weekend there is a CAT mega combat. Why we are calling it as mega? Because generally for 200 participants get the scholarship, but this time it is the 500 scholarship, 500 students who are getting the scholarship. So from that perspective, already if you have not taken the test yet, so this Sunday, that is 19th, I guess, yeah, 19th September, this particular Sunday, you can take this particular test and you can avail some of the scholarship. 19th September, 12 in the afternoon. It's just 1 hour test. 1 hour just flies. Try your luck. If you are in the top 500, you can reap some scholarships. Yep. That's pretty much the end of announcements as well. Yeah. Hmm. Fair enough. That's pretty much end there. Yeah, Rishav, is algebra priority, etc. Depends on what score you want. Right? Yeah, what score you want is the thing. That's it. So that's a priority. This is a priority. Yeah, everything is a priority because sometimes a very difficult question can come on time, speed, distance, which we don't want to do. And there may be a very, I mean, like very sitter kind of a question on algebra. Therefore, we wish to do. Right. So we will keep all our armory ready. We will select our battles in the cat. That is the whole thing there. Right. Yeah. So we need to select our battles. Maybe PNC I will launch on the plus course. Rishabh. Yeah, maybe PNC I will take there because something I'm taking on special class, something I'm taking on YouTube, something I will take it in the some module I will take it there. Likewise, I will break this up. Okay. Good night, guys. All right. I will see you guys on tomorrow. I'll see you guys tomorrow at 2ish in the afternoon. Yeah, all of you sleep well, eat well, rest well. I'll see you in the afternoon. Bye till then. Study well. God bless you. God bless you. God bless you.